Hi guys, welcome back to the SQL 50. So today we'll be solving the second problem in the joins. So the problem is product sales analysis 1. Okay. So we have been given two tables, products and sales. So if we go through the schema, we are having five columns. Okay. So we have sales ID, product ID, year, quantity and price. So we have five fields which are all of type integer, and they're saying that sale ID is the primary key combination of columns with unique values of this table, and product ID is a foreign key reference column to the product table. Each row of this table shows a sale on the product ID in a certain year. Note that the price is per unit. Okay. And the product table, we have two columns, that is product ID and product name. So product ID is integer and product name is a varchar. Okay. So this is the thing, guys. And if you see that uh, product table here, actually it is acting as a dimension table because it is containing the description of something. So just remember that these terms later, if we start the data engineering course, there I would clearly explain what are dimension and facts, but just remember that these are the product here is acting as a dimension table, which dimension means again means it will contain the description. Okay, description means what, like products. So here it is a product, so what it will contain, it will contain product ID. For each and every product it will have the name, and it would also have the brand and etc, many columns. So it's just it just describes the data. Okay. And whereas sales is acting as a fact table. So fact table means it will keep on growing, the data will be coming into it each and every day, right? So every day there are multiple transactions, every day there will be multiple sales that will be going on. So it is like, data will be adding into that table continuously. So I'm just giving a small information kind of stuff. So it is not related to this problem, but I'm on a general specific, like on a general knowledge, I'm just providing you that thing. So it will be useful when you are in data engineering. If not, then you can ignore it. Okay. So what they're asking now is, they're saying us to write a solution to report product name, year, and price for each sale ID in the sales table. So whenever we see that each sale ID in the sales tables means, for each sale ID in sales table means, automatically we will be getting, we need to get that thought, like get this small spark, like which join we have to use. So they're saying for each sale ID in sales table means, so automatically it is a left join. Okay, so it is sales left join product, because left join means what, every row in the left, every row in the left table will be, it will be on the output, and all the matching rows from the right table will be on the output, and whichever, for every left row table, whichever are not matched, all those right table values will be null. I hope this statement doesn't confuse much. If you are confused, don't worry. Let's solve the problem, and you can get clear that off. Okay, so they're asking us to find, we need to output product name. So you can see that there is so much of information here, and there is nothing much they're asking. So they're asking us to find product name, right? Product name, year and price for each sale ID. So you can see that, here the year and price for each sale ID means they're all in one table, sales. The only thing that we have to get is the product name. Okay, so joins, right? So joins is, when we want the data to be, when we want to query data from multiple tables, when we want to get the data from multiple tables, then only these joins come here. So, and remember, joins is an expensive operation. So people generally deal with it very, very seriously. Like they will put many optimizations. Otherwise, it would take, it would keep much overhead on databases. So generally people be very careful and avoid joins up to the most of the extent. But whenever they will perform a join, they will make sure that they filter the data before they are performing. Okay, just these are just insights, like whenever you will be going into a as a software engineer or data engineer, these tips might be just helpful for you. That's why I'm giving. So yeah, let us get back to the problem. uh, so you can see that product name is the only thing that we need to get from the product table. All the other columns are present in the one of the sales table. So yeah, so to get the product name we must use the joins. Okay. uh, so you can see, we'll go through the sample example. So we have been given one of the sample test cases, that is this, right? So now what we will do is we will just go through this, once we will go through this sample test case, and then we'll jump on to write the code. Okay, so you can see that we will try to understand the data first. Okay, we'll try to understand the data first. So sale ID 1. So this is the particular sale ID, or you can say it as a transaction ID or something. So these sales represent the transactions, whatever products have been sold and how much quantity has been sold and what is the price that has been sold and in which year it was sold. So that is what it is representing. Okay, so one the sale ID is one, product ID 100, right? And in 2008 it was sold, and 10 is the quantity that has been sold, and the price is 5,000. Okay, for sale ID 2, it is again the same product 100. In this in the 2009 year, 12 quantities of that product have been sold, and same again you can see 5,000. Maybe the product, right, the same product cost has been reduced in the next year. Who knows, right? We don't know that information. And sale ID 7, 200 product ID and this thing. So nothing, right? This is a small description of data, and then we have one more dimension table, that is product table, which is having all the names of that product. This can be product code or product ID. In here in this case I have given product ID. So what we have to do, we have to nothing but we have to display an output. What output we have to display along with the year and price? We have to get the product name. Okay, to that every sale ID. So every sale ID means we have to go through, like we have to give output in the output table. We have to give for every sale ID, we have to give that into output. So whether if it is like whether that product ID or product information is present in the product table or not, I have to get all the information. So what will happen generally, we'll be getting all the rows from sales table. So whenever there is a match, right, whenever there is a match in the right table. Okay, so if the product ID is present in my right table, I will get those I will get the product name for those IDs. If it is not present in my product, if whenever the sale ID and product name is not present in the my right side table, for those rows I will get null values. Okay, I hope you are clear. I mean, I assume that you are clear with the basics joins. So yeah, so so now we will just go and write the code. Okay, so yeah, so again we will start from the from table, right? So from table, so we are now joining two tables, right? So from sales, so again we will be using aliases here because we need to get columns from multiple, I mean we need to get columns from multiple tables. So it's better to use aliases instead of just it is very instead of if we try to not use this, we need to we may need to use the full table names, which is it is it is not relevant and not relevant also. So it is better to use aliases. So we'll be use this left join because for each sale ID we need to output in the target table, right? So left join products table, product P. So on which, okay, on which condition we have to join? So the common key is what? Product ID, right? So product ID would is the foreign key, right? It is a foreign key. It is a foreign key to the product table in the sales table, but here it is a primary key, right? So we'll be joining both these tables on the product ID. So s dot product ID equals to p dot product ID, right? So now what we will do, we will just select star and let us see what the output is. We will just understand, right? So what we are doing, I'm just joining two tables. So from sales left join product P on s dot product ID equals to p dot product ID. And if I run this, so I can see that all rows have been matched, right? So if you see, first we are getting sale ID 2 and it is having the product ID 100 and year is 2009 and 12 5000. Okay, 12 5000. Now it has been matched with the product ID 200 Apple. Okay, so this table here, this product ID and this product name, these are coming from, these both columns are coming from the right side table. Okay, my right side table is what, my right side table is product. Okay, these, so both these two are coming from my right table. So if you know, if this product ID 100 was not present in my right table, then I would get for both these rows, right, in the, this is the output table, right? So if the product ID 100 was not present in the right side table, then I would get for this, both these columns for this particular row, I would get null values. Okay, so yeah, in previous problem we have seen that. So yes, now we can, you know, so this is the left join, guys. So for every row, for every row in the left table, we will be getting corresponding all rows from the left table and only matching rows from the right table. And if at all there was no matching on the right table, for those values will be filled by null. Okay, yeah. So this, like this, we have joined both these tables. Now what we will do is we will simply select what they have asked. Okay, so they have asked us to report the product name, right? So again, so we can directly actually give, we can directly give, you can see here, product name, year and price. So if you see this, only product ID in the out, in the join table, only product ID is the ambiguous column. So if you want to report product ID also, then you must specify the table alias. You know, if it is not an ambiguous column, then you can simply give these names directly. There is no problem in it. But again, you know, for the industry best practices and for the readability kind of stuff, it is always recommended to use the alias, because whenever you you know, you code, like whenever you join an organization and whenever you are put into some data engineering or data migration projects, queries will not be like this simple. So you will be selecting 100 columns, there will be like queries which are having 500 lines of code. So it is always best practice to use the aliases, so that we will be understanding when you are debugging on, when you are backtracking to find a bug, you will be, it will be easily, you can easily identifiable like from where this column is coming from. Okay, so product name is coming from the uh, P. Okay, it is coming from the product table, and year and price are coming from the sales table. Okay, so now if we run this and run on the sample test case, I think it has already passed. So yes, so it has passed on our sample test case. We will check if there is any ordering. Okay, they have said that result can be in any order. So we will submit this solution. So yes, it has passed. And again, I don't want you to go through this runtime. This runtime is like, it is because I assume that it is because of the languages also. So I have seen some of the videos, like if they are, if they are submitting the solution in Postgres, it was very fast. They were, all solutions were coming in like it was taking very less runtime. So it is okay. We like it is okay not to focus on this very much. Okay, it is not it is like all the algorithms runtime, they are actually not measured by the they're measured by the algorithmic runtime, right? It is not by the, you know, execution, CPU execution time. It is on algorithmic execution time, right? So now we can also check the best solutions. So for most of the simple problems, all the solutions will be pretty similar. Okay, so that's it from this problem. I will meet you in the next problem. Thank you.